Hello friends, this video on electrochemistry part 15 is brought to you by examfear.com. No more fear from exam. Let's take similar numerical. We have to find the Nernst equation and the EMF of this cell at 298 Kelvin. First write the balanced equation for this. Sn becomes Sn2 plus. So we have Sn, this becomes Sn2 plus. Then H plus is reduced to H. So there are two hydrogen, there has to be 2H plus. This is my balanced reaction. Correct? This will be in aqueous, obviously. This will be in aqueous. This will be gas. This will be solid. Now we know that E cell we have to find is nothing but E naught cell minus 0.0591 by N log of Q. This equation we know. Q for this will be what? Concentration of Sn2 plus. Concentration of H2 will be 1 divided by concentration of H plus square. Why square? Because there is a 2. Correct? E cell we can easily find. You can easily find from this chart. Right? It will be nothing but, I'll show you. So E naught cell will be nothing but E naught of right minus E naught of left. What is the E naught of right? Right is this guy, that is H plus to H reduction. E naught of left, that is Sn plus 2 to 2 plus 2 Sn reduction. Please don't put the reduction because standard potential is nothing but reduction potential. This is 0 minus, and this value from the table we'll get is minus 0.414 V. Total is 0.14 volt. Positive. Correct? Let's plug the values. E cell will be what? E naught cell, that is plus 0.14 volt minus 0.0591 by N. There are 2 electrons transferred, if you see. 2 electrons into log of Q. Concentration of Sn2 plus, that is 0.05. Concentration of H plus 0.02 to the power 2. Correct? You solve this, you get plus 0.14 volt minus 0.002 volt. And that is nothing but mistake here. This point, it will come out to be 0.0619. Actually, yes. We saw this, the end result will be 0.078 volt. That is the answer. Similarly, we can solve this part also. Here also we need to first find the balanced equation. So the platinum is just a catalyst. Bromine is getting reduced to Br minus. Right? And sorry, it's getting oxidized because the oxidation reaction, right? So Br minus is getting oxidized to Br2, right? Br minus to Br2 is oxidation, and then we have H plus to H2. There is something wrong here actually. This has to be Br minus here and Br2 here. Anyway, so Br minus is Br minus to Br2, so it's to Br minus, and then H plus to H2 is the reduction. So H plus is getting H2, so there are 2 H plus here. Correct? There are 2 electrons transferred here. So Q for this will be concentration of bromine and hydrogen, both are gas, so it will be 1. Concentration of Br minus square, concentration of H plus square. This is the value of Q. Right? E cell, E naught cell you can find actually. It is nothing but E naught cell of hydrogen minus E naught cell of bromine, right? And that you will get as minus 1.08 volt. You can do it actually. For this reaction, we use the same formula. Nernst equation is nothing but E cell is nothing but E naught cell minus 0.0591 N by log of Q. Why? Because it's happening at 298 Kelvin. This value is minus 1.08 volt minus 0.0591 by 2 because n is 2 electrons, and log of Q is 1 by concentration of Br1 square, that is 0.01 square, and concentration of H plus square, that is 0.03 square. Right? Solve this. Minus 1.08 minus 0.21 is nothing but minus 1.29 volt, and that is my answer. You can solve it on your own. If you have doubt, then you can just watch this video. Using the standard electrode potential, predict if the reaction is feasible. See, the reaction is feasible if my Gibbs free energy is negative, and since I'm talking about standard, G0 is negative. If that is negative, that means my reaction is feasible, and this is nothing but minus NF. E0 is less than 0. These are all constant, right? They are all positive values. That means if E0 is greater than 0, my reaction is feasible, because there's a minus here and there's a less than sign here, right? E0 is nothing but E0 of cell. So if I can just find the E0 of the cell, which you get from these electrodes, and that is positive, that means the reaction is feasible. That's true also, right? If you have the electrode potential of a cell is positive, that means that will work, right? So in this case, I have Fe3 plus and I minus. So Fe3 plus, you can oxidize this because oxidation state can be +2, it can't be more than +3. So this Fe3 plus will be something which will get reduced, right? It will reduce. And I minus will be something will get oxidized, right? So NOx, red cat, reduce, that means this will be cathode and this will be anode. Correct? So E of cell is nothing but, you know that, E of right minus E of left, and E of, we're finding E0 actually. What is E of right? In this we have seen that we have anode in this side and cathode in this side, AC. So that is nothing but E of cathode minus E0 of anode. What is the cathode reaction? Cathode reaction is this way, E0 of Fe3 plus 2Fe. I'm talking the reduction reaction. E0 of anode, that is, again I'm talking about reduction reaction, so it will be I2 becomes I minus. From the chart we can put the value. This is 0.77 volt and this is 0.54 volt. That is nothing but 0.23 volt, and this is greater than 0. So if it is greater than 0, I can say that this reaction is possible. Correct? Let's talk about the second case. I have Ag plus NCU. Obviously Ag is plus is something which will get reduced, and Cu will get something oxidized. Again, NOx, red cat, oxidized means this is anode, and reduced means this is cathode. Here we have to find the E cell. E cell we assume is nothing but E of right minus E of left, and we have AC, anode on the left, cathode on the right, that is E of cathode minus E of anode. Since we are talking of standard, let's put E0 all the places. E0 cathode for is nothing but, this is my cathode, that is I'm talking about Ag plus to Ag reduction, and E0 anode I'm talking about Cu plus 2 to Cu reduction. Correct? See, there is a doubt here. I can take Cu2 plus to Cu also, or I can take Cu plus to Cu also, right? This is not given actually what kind of reaction will follow, because copper is getting oxidized. It can oxidize to Cu plus 1 or Cu plus 2, we don't know. So this becomes, this is 0.8 volt and this is 0.52. We solve this, you get 0.28 volt. Even if you take the other one, this is instead of 0.52, it is 0.34 volt. So in both the cases actually 0.8 minus 0.52 or 0.8 minus 0.34, you get the value which is greater than 0. Thus, I can say that yes, this reaction is possible. There is a confusion here, but in both the cases, I get a positive value of the E0 cell. So in the similar format, you can do all these questions. I won't solve for you, but this I'll show you. This is not feasible. You can try on your own. This is also not feasible, and this will be feasible. For this E0 E cell, that will come out to be minus 0.32 volt. For this, it will come out to be minus 0.03 volt, and for this, it will come out to be 0.32 volt. You can just tally this. You can solve this in the same style. As I told that this Nernst equation is also used to find the pH. Here is a reverse question. If the pH is given, you have to find the E of the cell. Right? We have to calculate the potential of hydrogen electrode, which is in contact with the solution whose pH is 10. So pH is 10 means what? pH is 10 means hydrogen plus ion concentration is nothing but 10 to the power minus 10. Correct? pH is X, that means H plus is 10 to the power minus XM. The reaction we have is for the hydrogen electrode is H plus, you get electron, you get hydrogen gas, right? So E cell is nothing but E0 cell minus again 0.5091 by N log of Q at standard condition. Its E0 cell is 0 minus 0.0591. Number of electron transfer is 1 log of Q. What is the Q? Q is nothing but concentration of hydrogen gas divided by concentration of H plus, right? This is 1 by concentration of H plus. Correct? So this you put the value, that is nothing but minus 0.059 by 1 log of 10 to the power minus 10. You solve this, you get 0.591 volt with a negative sign, and that is my answer. Correct? Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.